Hello everyone. So this is a question from JEE Advanced 2025 paper 2. The sum of the spin-only magnetic moment values in Bohr magneton of Mn Br6 3 minus and Mn Cn6 3 minus is. Okay. So the chapters involved is coordination compounds. The spin-only magnetic moment is mu. Okay, and mu is obviously equal to root of n plus 2 Bm. The units of mu is Bm, that is Bohr magnetons, where n is the number of unpaired electrons. This n is the number of unpaired electrons. In both MnBr6 3 minus, that is this guy, and MnCn6 3 minus, the coordination number, and coordination number is the number of coordinate bonds formed with the central metal atom oblique ion by the ligands. Okay, so in both of them, the coordination number is 6. As you can see, there are 6 Br minus as ligands, and here also we have 6 Cn minus as ligands. Therefore, both the complexes will be octahedral complexes. There is no doubt about that. And their hybridization can be either D2sp3 or sp3d2 whenever the complex is octahedral. Okay, so both have coordination number 6. Therefore, complex is going to be octahedral, and the hybridization can be either D2sp3 or sp3d2, either of these. So let's determine. Okay, so let's talk about MnBr6 3 minus first. So assume the oxidation state or the number of Mn as x. So therefore we can write x plus 6 into minus 1, because Br minus is the ligand, so the charge is minus 1, which is equal to minus 3. So therefore x is going to be plus 3. And configuration of Mn, we know it is 3d5 4s2, which we can represent as in this fashion. So this is 3d 4s 4p and 4d vacant. Okay, and configuration of Mn plus 3, because the oxidation state of Mn is plus 3, so Mn plus 3 will be, obviously we have to remove electrons from 4s and one from 3d, so we are left with 3d4. So 3d4 can be represented in this fashion. And obviously we have these vacant orbitals present. And the ligand is Br minus, and it is a weak field ligand, therefore it cannot cause pairing. Very important. Okay, so Br minus cannot cause pairing since it's a weak field ligand. Therefore, since it cannot cause pairing, there will be 4 unpaired 3d electrons in Mn plus 3. So these guys will remain as it is. Therefore, it will form sp3d2 hybrid orbitals. Okay, therefore the hybridization is going to be sp3d2. To show those hybrid orbitals, I will represent the orbitals 1 2 3 4. So this is 3d, so they are unpaired. Then we have 4s, then we have 4p, then we have 4d, 5 of them. So these 6, that is 1s orbital, 3p and 2d. So these are the 6 empty sp3d2 hybrid orbitals which are utilized. Okay, 6 empty sp3d2 hybrid. Okay, so therefore Mn plus 3 ion provides 6 empty orbitals, that is these guys, to accommodate 6 pairs of electron from the 6 Br minus ligands. Remember, we are surrounded by 6 Br minus ligands, so the formation of MnBr6 3 minus in a nutshell can be represented in this fashion. So we have 1 2 3 4, 3D 1 2 3 4, and 4s, 4p, and 4d. And the electrons that is donated by Br minus can be represented by cross, since there are 6 pairs of them. So there 1 2 3 4 5 6. Okay, so the spin only magnetic moment mu of MnBr6 3 minus will be, obviously there are 4 unpaired electrons, so therefore mu is going to be root of 4 into 4 plus 2, that is root of 4 into 6, which is 2 root 6. Okay, so this is mu for MnBr6 3 minus. So let's talk about MnCN6 3 minus, that is for MnCN6 3 minus. So let's assume the oxidation state or the oxidation number of Mn as x. So x plus 6 into minus 1 will be equal to minus 3, because our ligand is Cn minus and it carries a charge of minus 1. So therefore x is going to be plus 3. And the configuration of Mn is 3d5 4s2, which can be represented like this: 2 3 4 5. This is 3d 4s 4p. Configuration of Mn plus 3, because Mn exists in plus 3 oxidation state. So therefore configuration of Mn plus 3 will be, obviously we have to remove 2 electrons from 4s and 1 from 3d. So it will be 3d4, which can be represented in this fashion. So 1 2 3 4. This is 3d 4s 4p. Okay, and the ligand here is Cn minus, which is a strong field ligand, and it is only after CO in the spectrochemical series, lies towards extreme right after CO. Therefore it will cause pairing in Mn plus 3. So these guys will pair up. Okay, and obviously they will pair up to form or to give D2sp3 hybrid orbitals. Okay, so it will show D2sp3 hybridization. So therefore it will look like this. So these guys are going to pair up and we'll be left with 2 vacant D, because it shows D2sp3 hybridization. So therefore 2 will pair up and 2 will remain single. So this is in the 3D. Then we have 4s, then we have 4p. And these 6 empty D2sp3 hybrid orbitals are being created. Okay, now Mn plus 3 ion provides 6 empty orbitals to accommodate the 6 pairs of electron from 6 Cn minus ligands, right? So therefore formation of MnCN6 3 minus can be represented by this diagram. So this is the situation after pairing, and these guys are vacant, so they will accommodate the electrons that is donated by the ligand, and there are 6 pairs of electrons, so there will be total 12 electrons. So 2 here, 4 here, 6 here, 8 here, 10 here, and 12. So there are total 12 electrons donated by the ligand. So therefore the spin only magnetic moment, that is mu of MnCN6 3 minus, will be obviously root of 2 into 2 plus 2, because there are 2 unpaired electrons. Okay, so therefore this is going to be root of 2 into 4, which is 2 root 2. Okay, and in the question they are asking us the sum of magnetic moment of MnBr6 3 minus and MnCN6 3 minus, which is going to be 2 root 6 plus 2 root 2. And when you do this calculation, we will approximately get 7.727, which can be rounded off to 7.73. So therefore their sum of magnetic moment is 7.73. This is the answer. So the sum of spin only magnetic moment values of both of them is 7.73. Okay, thank you.